Okay, now we're recording. All right, so continue writing. Continue writing. All right, about 30 more seconds. All right, so as you continue, I will leave it up on the screen, but I do want to go ahead and take a look at these two triangles. All right, so take a look. What types of relationships do you guys notice between the two triangles?
Big triangle, small triangle.
Big triangle, small triangle. Okay. They're the same but big. Okay. Anything else?
Random number.
Okay, there's numbers. Are they random though?
I just put that just to make it sound more cooler.
Ooh. Okay, Alejandro put a number up there. Alejandro, what value is that? What are you referring to?
X.
X. So you're telling me that X is 3.75. Now, how'd you get that?
Easy, because I basically just divided freaking 16 with freaking 6. Why am I saying that too much? And freaking divided freaking 8 with freaking.
Just
Why
speak
are you
like
such a potty mouth?
Talk to me like I'm your teacher, because I am.
That's the hard part, but 16 divided. I can't freaking see. 16 divided by 6 is 2.667, blah blah blah. And freaking a divided by 3 is 2.66.
Okay.
67. You freaking divide that with 10, you get 3.75.
Okay. So I'm gonna kind of summarize what he just said. So we know that, for example, AB corresponds to A prime B prime, right? And what we have is there's a scale factor. So we just wrote that down. The scale factor is the ratio of the lengths of the corresponding sides. So basically what we're doing is you would take, the way that we want to do this is always take the image over the pre-image. This is our scale factor. Hold on, let me write this down. Image over pre-image. So if I'm talking about AB and then A prime B prime, that's going to be 6 over 16. That's my ratio. Now, if you actually divide that, if you go ahead and divide what's 6 divided by 16, six divided by 16, what? 375, right? 0.375. Now let's do the same thing with BC. BC and B prime C prime. That would be 3 over 8. What's 3 divided by 8? It's the same, right? 0.375. Well, now I've got this missing side length. I know that AC is 10, but I don't know A prime C prime. However, I know the relationship between them. I know that in order to go from one to the other, the scale factor is 0.375. So I know that x over 10 is 0.375. I know that that's the relationship. If I do x over 10, it should give me 0.375. Well, like Alejandro, like Rios just said in the chat, this is basically like a little equation. We're just going to solve it for x. And what you do to both sides is you multiply both sides by 10 to get x by itself. And when you do that, I know that x is 3.75. So once you know the scale factor, you're able to figure out if the two shapes are, if it's a dilation and there is a scale factor, then you can find the length of any missing side based on that scale factor. So questions on that? We'll do a few examples in a little bit, but that's how we got 3.75. And Perla, no, remember, because pre-image is what comes before. So the original one is the pre-image, and then the one with all the primes on it is the image. It's the one that was created. Exactly. All right. So let's go ahead and take a look at, I have to put up a video because this is something that, remember back in the day, we were, okay, how do you draw a triangle circumscribed in a circle and an inscribed triangle and all of these different types of drawings? Well, there's one more that we need to learn about, but give me a moment to open up that page.
Today, we learned.
So what I want you guys to do is, as you watch it, I will post this video later on Teams, but for now, I'm going to play it twice. The first time, I just want you to watch it. The second time, oh, I didn't ask you guys to bring your protractor, did I? Okay. So right now, you're not going to draw it, but later on tonight, I'm going to put that as kind of like a homework assignment. Since I'm not assigning any Khan Academy this week at all, this will be the only thing you have to do tonight. So I'll post it on Teams later. Say that again?
I have a protractor right here.
Well, if you haven't now, you might as well do it now if you feel like doing it now. But like I said, you don't have to do it right now. You can do it later tonight.
But I wanna.
Then go for it. Now you have, I'll give you guys until like Sunday. So if you don't have a protractor or a compass right now, then just make sure you get one by the time it's due. Okay, here we go.
Today, we learned how to construct dilations. And in a dilation, what we're doing is, based on some point, I'm going to call this point P, we can either enlarge or shrink a figure based on a scale factor that we're given. So for example, let's say we're given this triangle ABC and we want to construct a dilation of it with a scale factor of 2 based on this point. So what you're going to do is draw a line from this point through each vertex and take the distance of that from point P all the way to point B. It's going to be this long. So if the scale factor is 2, what we're going to do is take this distance and repeat it out here. So now all of a sudden, that distance that B is away from P has doubled. So that is my B prime. And continue that for each of the other vertices of your triangle. And you'll have the dilated image. So let's see, I'll do A next. I might have to make that longer, but here. There's P to A, so I'm gonna have to double that. Yeah, I'm gonna have to make it a little bit longer. There we go. So there's our A prime. And then for B, or C, I'm going to take this distance from P to C. It's about right there. And double it. And this point will be my C prime. So after I connect all the dots,
That seems easy.
you'll notice
It's not bad at all.
that with a scale factor of 2, it makes the exact same shape as the original, but each of the side lengths is twice as big.
Pausing here, I just want to point out a couple of things. First of all, that point P, we wrote this down. This is the center of dilation. So that point is where you base everything off of. And then this was a scale factor of 2, which is why he was doubling all of the distances.
Also, the distance of each point from point P has doubled. So now, from this to this, it's twice as far away. All right, so that would be a scale factor 2. Now,
Yeah,
let's
Tyrone,
say, for
do a
example,
triple
though,
it. Mhm.
I didn't want a scale factor of 2. Maybe I want a scale factor of 3. In that case,
There you
I
go.
would take this, and instead of going 1, 2, I'd go one more, 3. So then C prime would have been way out there. And it would have been 3 times as far away from point P, and the figure would have been 3 times as large. Now, on the other hand, I could ask for a scale factor of less than 1, like a fractional amount. Let's say a half. If I want a scale factor of half, then I'm going to have to take this distance and cut it in half to find where C prime would be. So let's actually do that. So to find the halfway point of this, what I need to do is construct a perpendicular bisector. And we already know how to do that.
Now, this part
swing
you
an
don't
arc
need
on
to know how
each
to do, but I'm
side
just going to let it
of
play so that we
this.
can understand it.
There we go. Drawing my line. So what I just found here is the midpoint of the segment PC.
That's a little bit of a
So
review there.
this would be my C. I'm going to call it double prime because it's a different one. Okay? So that is the scale factor of 1/2 for point C about point B, about point P. Now, just do that the same thing for the other segments, and we can construct our entire triangle with a scale factor of 1/2. All right, so let's see. There's the perpendicular bisector. There's the midpoint. There's my A double prime. And then finally, for P to B, there and there. perpendicular bisector. It gets a little messy with all the perpendicular bisectors, but there's the midpoint, B double prime. And so, if I connect up those points, there's my new dilated triangle. So notice, the scale factor of 1/2 shrinks all the side lengths down to half the original length, and the distance of each point to the center of dilation has been also cut in half. So there you go. Original figure, scale factor of 2, scale factor of 1/2.
All right, so not too bad at all. I'll show you again, I'll post this on Teams later, and I'll tell you exactly what scale factor I want you to try and the shape that I want you to draw. So it might not be a triangle, we'll see. Might make it a little more challenging. All right. So back to where we were. Now here I have the properties of dilations. You guys always know on the first day of a new topic, there's just going to be a lot of definitions. It is what it is. So I will give you guys plenty of time to write all of these down. Go ahead and begin now. And I'll start with about 3 minutes. Oh, I'm sorry if I lagged. Right now, you guys are just writing these properties down. I put 3 minutes on the clock, and then I'll see how much more time you need. All right, there's about 20 seconds remaining. So let me know in the chat, how much more time do you need? Oh, you're done? A couple people say they need a little bit more time. I'll add another minute. Okay. All right, so time is up. However, I'm going to leave this up for just a minute to explain parts of it that maybe are a little confusing. So first of all, dilations preserve angle measure. In other words, angles don't change. Angles stay the same. Even though the figure gets bigger and smaller, if A is 60 degrees, A prime will also be 60 degrees. Exactly. So angles stay the same. Okay. Now, now betweenness basically says like, the word betweenness is kind of weird, but it basically just means like, if, if point P is in between point A and point B, then P prime will stay between A prime and B prime. So it's basically saying that the positions don't change. So wherever things are located, it's going to get bigger, but it's not going to like move around or rotate or reflect or anything like that. Okay, dilations preserve collinearity. That kind of goes with the same thing. Like collinearity, what is that? What words are in there that maybe we can piece together what that means? Co, okay.
Duo.
So co and then linear, right? So what that means is if something is on the same line, for example, I'll draw a little example. If I have a line and I have M and I have point D, well, if it dilates, if it gets bigger, if M is now, if the distance doubles, let's say, it's still on the same line. Even though it got larger, it still stays on the same line. So again, that kind of goes with the same idea that even though things might get bigger, they're not going to flip around or rotate or end up somewhere completely different. They're just going to stay, they're going to keep the same relationships. Okay. And then preserve orientation. Again, same idea. The position of the figure is not going to change. So all of those kind of mean the same thing. Then it says dilations map a line segment, the pre-image, to another line segment whose length is the product of the scale factor and the length of the pre-image. So this is basically telling us about what a scale factor is, which we already kind of talked about, but the image, the new image, will basically be multiplied from the pre-image. And then finally, dilations map a line not passing through the center of dilation to a parallel line and leave a line passing through the center unchanged. So this one's very important. I definitely want to go over this one. I want to see if I can, okay. This is kind of bad, but trying to zoom into what he drew in this example. When he drew the image, A prime, B prime, C prime, let's just take a look at A, B really quickly, and then A prime, B prime. Those two lines are parallel to each other. See that? And that actually goes for every single combination. My purple lines are also parallel to one another. And then these orange ones as well. So when you dilate a figure, you actually end up creating parallel lines. Do I have any questions on that? Awesome. Okay, so that is what that final bullet point is talking about. So dilations create parallel lines. Any questions on the properties that we have written down? Okay, awesome. All right. So determining scale factor, we kind of did this before when we were working on when we were writing down what a dilation is, but we also have to be able to do this on a coordinate plane, and sometimes that involves doing the distance formula. So Rios, your favorite time of day. When you're trying to determine the scale factor, remember that the scale factor is always going to be the image in the numerator. So it's image over pre-image. Okay, that's something super important because sometimes if you get it backwards, that's going to mess you up. So I'm just going to keep that there. Now, in this case, which side length do I not need the distance formula for?
It's hot in here. Can you turn on the AC?
Eric, damn it, you stole my pun.
That was good. I was not expecting that. That was, yep. Okay. So we got
Alex, I
AC.
swear.
How long is AC? AC is, looks like 3, right?
Freaking 3.
Freaking 3. What about A prime, C prime?
6.
6.
Cinco. Wait a minute. That's 5. I'm dumb.
So my scale factor, what is it? Is it 6 over 3 or 3 over 6?
It's 3 over 6, meaning that freaking A is no, from the number. You understand, like the non-prime number. Which one? How do you call that? I don't know, but it's freaking divided by 2.
Okay, but be very careful. Which of these is the image and which one's the pre-image?
ABC.
ABC is the
small one.
What is that, guys? Is that the
The
image?
pre-image.
Okay, that's the pre-image. And then this one is my image. So when I write my scale factor, think again. 6 over 3 or 3 over 6? You got it, Janelle. 6 over 3. 6 over 3, because again, you go from the new one divided by the old one. So it's 6 over 3, which is 2. Scale factor is 2. So now, if I want to find all the rest of the lengths, well, let's go here, AB. I'm going to need to use the distance formula. Okay, B is 3, 1, A is 1, 3. So I've got 3 minus 1 squared plus 1 minus 3 squared. Yeah? Now, 3 minus 1 is 2. 1 minus 3 is negative 2. I got 4 plus 4. So I've got the square root of 8. Agreed? Any questions on that?
Agreed.
Agreed. Okay. Well, if AB is the square root of 8, what's going to be A prime, B prime? What should be A prime, B prime? Based on the scale factor.
Two times the square root of 8.
2 times the square root of 8, yeah. 2 times the square root of 8, because to get from 3 to 6, you multiply by 2. To get from square root of 8 to x, or whatever we're trying to find, you multiply it by 2. But we can also just verify that. We can check it out just to be sure that we got the right answer. So we can do the distance formula for A prime, B prime. This is 6, 2. This is 2, 6. So then here I would get 2 minus 6 squared plus 6 minus 2 squared. 2 minus 6 is negative 4 squared, and then 4 squared, I get 16 plus 16,
32.
32. But hold up, I thought it was 2 times the square root of 8.
Divide? Wait, no. Tyrone says 64 though.
Well, it's definitely the square root of 32, but who can remind me? If I have the square root of 32, it's going to equal the same thing because there it is, Emily. Emily says, okay, 32 is the same as 8 times 4. 4 times 8. And you can take the square root of 4. This is the square root of 4 times the square root of 8. Well, the square root of 4 is 2. So that's how we get 2 times the square root of 8. So we are correct, right? We definitely have a scale factor of 2. So now let's find the last one, CB or BC. Go ahead and on your own use the distance formula to figure out the distance of CB. And then once you've got the distance of CB, figure out the distance of C prime B prime. I'll give you guys a couple of minutes to work on that. All right. 2 minutes are up, so wherever you are, I'm just gonna start it and then we'll see if we get the same answer. So C is at 4 comma 3. So CB, that's gonna be 4 minus 3 squared plus 3 minus 1 squared. So I get 1 squared plus 2 squared, which is 1 plus 4 square root of 5. Square root of 5. So if this is the square root of 5, what is C prime B prime going to be?
Pretty sure the square root of 10.
Pretty sure the square root of 10. What do we think? Agree? Disagree? Tyrone says no. Okay, Tyrone, what do you think? Never agree with Jalen. Janelli says no. Okay. So Janelli's, you went and you calculated it fully, right? And you got 20. Did you get 20 or square root of 20? Because if you go through, you should get, good, you should get square root of 20. So it's not the square root of 10, it's the square root of 20. But
I'll just
square
be
root of
quiet.
20, that's okay. No, this is good because we're understanding. The square root of 20 is the same as 4 times 5, right? Right? 4 times 5 equals 20. Well, what's the square root of 4? 2. So this is 2 times the square root of 5. Which, remember, what's our scale factor? Our scale factor is 2. So that's how we get the the answer, okay? You can't multiply. When you multiply a radical, you don't multiply inside of the radical. You keep it separate. Kind of like how when you have a variable, like 2 times x, you can't combine those. They're not like terms, so we just keep it separate, 2x. Same thing here. Square root of 5 times 2 is just 2 times the square root of 5. 2 square root of 5. Now, I'm going to erase a lot of stuff here because we do have quite a bit written down. I want to keep it nice and simple. So here's we figured out, okay, the scale factor is 2. From the pre-image to the image, it is doubled. Now, we figured out the scale factor. Let's also think about, because we also need to understand this, where would be the center of dilation? Where would be the center of dilation? Now, when you think about this, remember that the center of dilation, and I'll go back to this example, is kind of like the place where all of these lines meet up. So when you connect B prime and B, when you connect these 2 points, when you keep it going, let's just make it super, super long. When you connect every single pair and just kind of keep it going, all 3 of those lines are going to meet up at the center of dilation. See what I mean there? So if I connect A prime and A and just make a really long line, B prime and B, make a really long line, C prime and C, make a really long line, all 3 lines are going to meet up at the center of dilation. So let's take a look at our example. I'm going to go ahead and connect A prime and A and just kind of extend that line. B prime and B, extend that line. C prime and C, extend that line. Where do they all meet up? At 0, at the origin. So the center of dilation is the origin. And that's always how it's going to go. It's not always going to be at the origin. It can be in different places, but no matter where it is the place where those lines will always meet up. Any questions on that? All right. So here's a couple of examples. I think let's only do number 12 because I don't want to take too long on this. But look at number 12. We're going to figure out 2 things. This is on your own now. Determine the scale factor and determine the center of dilation. All right, so go ahead and get started on that. A is the pre-image and B is the image. So it goes from A and it grows to make B. Go ahead and get started. All right, guys, about a little bit less than 2 minutes remaining. All right. Now, wherever you are, I want you to pause wherever you are, and let's see what we can come up with together, because I'm sure everybody was working on a different part of this. Did anybody get any side lengths that I can write down? Be it the purple, red, orange. Can anyone give me any of these side lengths, or was everybody just sitting for 5 minutes and staring at the screen? Okay, Daniel, good. I'll have a talk with your mom later. All right, so orange, Janelle's got square root of 5. Good. Square root of 5. Anybody else? Anything different? Or any other side lengths? So for 5 minutes, the only thing everybody did in 5 minutes was get the square root of 5? Okay, Emily got square root of 10 for red. That's correct. Anything else? Did anybody get any of the distances of the larger triangle from B? Okay, so Janelle says for the orange one, she got square root of 20. That is also correct. Good. Anything else? Anybody? You think you got the scale factor? Anybody else? I'm a little disappointed. I'm thinking about giving a pop quiz right now. Okay, I've decided. Pop quiz. Distance of, I'll call this x and y. Find the distance of xy. Find the distance of xy. Put it in the chat privately. You have 2 minutes. This is an A, C, or F. You do it, you get it right, you get an A. You do it, you get it wrong, you get a C. Don't do it at all, that's an F. 2 minutes on the clock. Use your eyes, Daniel. I wrote it down. I'm not going to repeat myself. 1 minute remaining. All right, that's time. All right. Those who sent me your answers, you got it. Those who did not, did not. Emily, you got it right in the nick of time. Good job. All right. Now continuing on, the distance of xy was the square root of 53. Square root of 53. Okay, so here's what we've got so far. We got square root of 5, square root of 20. Then we've got the square root of 10, and then we've got the square root of 53. First of all, I want to see what the scale factor is, right? So basically what I'm trying to figure out is, how do I go from the small one to the big one? What would I have to multiply by? Now let's think about square root of 5 and then square root of 20. Okay. Let's rewrite the square root of 20. How can I rewrite square root of 20? Good, Perla. Square root of 4 times 5. You could also do 2 times 10. But when you try to figure out which numbers they are, always try to think of one number that is a perfect square. So for example, I could take the square root of 4, but if I did 2 times 10, you can't take the square root of 2 and you can't take the square root of 10, so that doesn't really help you out. Whereas 4 times 5, I can take the square root of 4, that's 2. So I'm left with 2 times the square root of 5. Well, how do I go from 5 to 2 root 5? Yeah, times 2. Exactly, times 2. Now, another way you could do this would be to actually go to your calculator and figure out what's the square root of 20 and what's the square root of 5 to the nearest hundredth. What would you get for square root of 20? Just with your calculator. Good, 4.47. How about square root of 5 to the nearest hundredth? 2.23. Right? Then scale factor is the pre-image over the image. So that's going to be 4.47 over 2.23. What do you get? $2.00444843. Now, since there's other numbers there, that's because we didn't, when we decided to make this to the nearest hundredth, obviously that number is actually a lot longer. So we're cutting it down a little bit, which isn't going to give us a perfect answer in the end, but you can round it to 2. So the scale factor is 2. Now, my red distances should also be 2. Should, but let's find out. Calculate, you can do it in your calculator. Square root of 53. What's the square root of 53? $7.28. What's the square root of 10? $3.16. Now divide. Do you get 2? $2.3. 2.3. Interesting. So what do we think? Is it actually a dilation or is it not? No, right? Because what has to happen is this, in order for it to be a dilation, that scale factor has to be exactly the same every single time. And since this one's a little bit off, just by a little bit, it's actually not a dilation. So that is kind of the last point I wanted to make. Tomorrow, I have some practice problems. We didn't get to them, but that's fine. I didn't think we would. So all of these practice problems will be for tomorrow. There will be a short quiz at the end of tomorrow's class, so please make sure that what we learned today, if any part of it was a little hard or troubling or you were confused, make sure that you're reviewing, rewatching the video, try your best to understand it and ask questions tomorrow when we do our practice problems. All right. Any questions before I let you guys go for today? Oops. Any questions? Tyrone, you don't think you can get one by Sunday night? You can't stop by like Publix? Even at Publix, they have them. Publix, Walmart, Target, all of those. Okay, see if you can. If you definitely can't, I'll see if there's something I can do that you might be able to borrow one, or I might be able to like mail you one or something like that. I'll see. Okay. Anybody else who doesn't have a compass or protractor? Okay. Yeah, you need both. Protractor doesn't really help too much. You need both. You just have to find yours. Okay. Get searching. You don't want to lose your protractor. It's a very valuable item. Alrighty, guys. That's all for today. Thank you for your participation. I love it when you guys participated really well today. I appreciate it. So I'll see you guys tomorrow. Have a nice rest of your day. Oh, and those students who still have to finish iReady, so Janelli, Samaj, Rios, and Eric, tomorrow, 8th period. That's it. So if you can find any time at all to do it before that, to catch up as much as possible, try your best so that you're able to finish it tomorrow. Alrighty? Okay. Bye, everybody.
Bye, Miss.
Bye.